one thing I want you to get out of this, okay, we're in vertex form, and what you're seeing is the equations today given to you in vertex form. And we're not always going to have to use the same values for x. Okay, yesterday we did always use, I think all of you used -1, 0, and 1. I added the -2 and the +2. Where was our vertex almost always yesterday? 0, 0. Okay, on this graph, we used these values. Where's the vertex of this graph?
-3, 1.
This would be the vertex down here. And that point is at -3, +1. Okay, if we go over to the other graph, these are the values we ended up using. Here's the vertex down here. What are the coordinates of that vertex? +2, -4. Now I want you to look at where the vertex is at on the parabola and the equation.
What's the vertex again?
Look at the vertex on the graph and look at the equation. I just want you to turn around to somebody next to you and tell them how you get the vertex from the equation.
You look at the
Quickly.
You look at the number.
inside,
So
and then the outside is
and then you
see how it says whatever numbers on 3 and do the opposite, and you keep it same for the outside.
Yeah, I was listening.
whatever numbers on the inside parentheses, you switch the.
Okay, so who can tell me where the vertex is coming from? Carrie, you had your hand up. No. Katie, go ahead.
So the x value, it switches whatever, the opposite of whatever.
Okay, so what's inside the parentheses
+3.
and the vertex? What happens? What's the relationship between those?
Switch the
Okay, the sign's the opposite, right? So it's x plus 3 in the parentheses, and the vertex was located with a -3. And then how about the y value?
It's the same as the outside.
It's the same as the outside number. So when I look at the equation that's in vertex form, I can know right where the vertex is. Same thing over here. If I look at what's inside the parentheses, I'm going to use that opposite. So +2 was where the vertex was. And then I take the outside number, -4, and I leave it. So I'm taking the opposite of what's inside the parentheses, but I'm using the value on the outside. That's where your vertex is located. So Ryder, one question you had for Sophie was, how do I know what values to put in? Well, if you can look at it and determine where the vertex is going to be located, you know that that value needs to be in your table. And then if you just find a value that's less than that x and a value that's bigger than that x, you'll have enough to draw your U shape.
Whoa.
Okay? If I know where the vertex is at the beginning, then I know that, hey, there's where my vertex is. If I just put an x value in that's less than that and an x value that's bigger than that, I'll have my U shape. So that's what's going to help you, and Sarah, I think you asked the same question. That's what's going to help you decide what x values to plug in, is knowing where the vertex is located. Okay? So I want you to write this down in your notes. The quadratic function in vertex form. What that vertex form is y equals a times, in parentheses, x minus h, quantity squared, plus k. That's what vertex form is in general. Write that down somewhere in your notebook. So the vertex of the parabola is coming from the h value and the k value. We'd say the vertex is at hk.
Opposite h?
No, it's hk, and here's why. In the formula, it's x minus h. So if I were to take x minus h and set it equal to 0, how would I solve that for x? How would I move the h? I would have to add h to the other side, so I'd get x equals h. Okay, so that x value that I'm using for my coordinate on my vertex is the h. So if you think about that one equation that we had that was x plus 3 quantity squared plus 1, this is my x minus h. So if I said x plus 3 equals 0, so if I put it equal to 0, I'd have to subtract 3 and get x equals negative 3. So the sign changes. It does not change with the outside value, however. If it's a minus, then it's negative in your coordinate. If it's a plus, it's a positive in your coordinate.
What?
Okay, let's graph one more.
Oh,
Okay, put this in your notebook.
Which one?
Example 5.
the only one I
So it says y equals 1/2. That's your a value still. We had an a value. Yesterday we talked about the a value. So this still has an a value. So 1/2 is my a. Here's my x minus h squared plus k. So when I make a table of values for this, when you look at that equation, where is the vertex going to be?
-3, -4.
-3, -4. So in my table of values, I want to put -3 and -4. Sophie. Yeah. And then I'm going to put a value that is less than -3, so I'm going to put a -4 into the equation. And I want a value that's bigger than -3, so I'm going to put a -2 into the equation. And it doesn't have to be within 1. You know, I could put a -5, and I could put a -1 in. I just want a value that's bigger and a value that's smaller. So if I plug that into my table, -4 plus 3 is -1. I square,
1,
and then I take it times 1/2.
1/2.
So you get 1/2 minus 4. What's 1/2 minus 4? -3.5, or 3.5. Okay, if I put the -3 in, I should get -4. If I put -3 plus 3, that's 0. Square root is 0. Times 1/2 is 0. Minus 4, yes, that does work out that it's -4. If I put in a -2, -2 plus 3,
1,
squared,
1,
times 1/2,
1/2.
that's still 1/2 minus 4,
3.5.
-3.5, where there's your repeat values that we need in the table. So if I plot those 3 points, they're going to ask you 3 things about your parabolas today. They're going to ask you, number 1, where's the vertex at? And you already answered that for me. On this parabola, where was the vertex?
-3, -4.
-3, -4. You just put the vertex down as an ordered pair. Sarah, that's the lowest point on our parabola in this example. The axis of symmetry I talked about briefly yesterday. The axis of symmetry is where you draw the line that goes right down the middle. The axis of symmetry always goes through the vertex, but if you were to fold that parabola on that line, everything would match up on both sides. The points would be identical on both sides of the parabola. Because what kind of a line is that?
Symmetrical.
It makes it symmetrical, the same on both sides.
Vertical.
It's a vertical line, and from chapter 3, a vertical line is x equals or y equals?
Y equals.
No,
X equals.
x equals. Okay, when it's a vertical line, only x is present in the equation. And you're going to say x equals, and then where, if it goes through the vertex, what does the x value equal at the vertex? The negative 3. So you'd say your axis of symmetry is x equals negative 3. Don't just write negative 3 down. It's an equation because it's representing this blue line. So you'd have to say x equals negative 3 for the axis of symmetry. And then the direction. Is it opening up or is it going to open down? Up. And yesterday we learned about the a value. Here's the a value right there. It's a half. Because it's positive, it's opening up. It's a fraction. So when it was a fraction, that U shape from the parent did what? Did it get skinnier or did it get wider?
Wider.
It got wider. So that's why this U is wider than our parent function, because of that 1/2. If that were a 2 or if that were a 3, you would see that U get skinny, and it would go up more quickly. Okay, so questions on that? Are we good with axis of symmetry?
I hope so.
Okay, and you don't need to write this down, but you'll have questions. I just want to go through this. Like question number 8, it says, write the function in vertex form for the parabola shown. So I'm going to give you a parabola, and you're going to write the equation for it. So that equation again is y equals a times x minus h, quantity squared, plus k. You've got to read the graph and put in the values. So again, what's h and k representing? The vertex. So where's the vertex on that?
-1, -3.
There's the vertex right there, -1, -3. So I'm putting the -1 in for the h. That becomes x minus a -1.
Minus 3.
And when it's minus a negative, what happens there? Leave, change. So it's going to become x plus 1, quantity squared, and the k value is a -3. Now we still have to come up with the a value. The a value is it skinny or is it wider? If you remember the parent function, y equals 1x squared from yesterday. Okay, when we graphed that, we put in a -1, a 0, and a +1. When I put in a -1 and I squared, I got 1, 0, and 1. So when I graphed that, here's 0, 0, 1, 1, -1, 1. So on that, when it went from the vertex to the first point, it went over 1 and up 1. What's this one doing? To go from the vertex to the first point, it's going over 1 and up 2. So this is going to be a 2 in front of there. It's going to go up twice as fast as the parent function did. Okay, if it's more shallow or wider, then you're going to see maybe it'll go over 2 and up 1. That would be a half for an a value. It's going up at half the rate. Okay, so the a value is something you kind of have to just look at and compare what happened to the parent and what's going on now. Okay?